Topic 3 of Unit 5, Freshwater Systems. No picture of me in the corner. I've got a bad case of the bedhead today. That's a joke. Anyway, there are certain sections that we will leave out, and I'm trying to just focus on the ones that you need to know the most here, okay? Let's start it here at the top. In Topic 1, you learned that less than 1% of Earth's total water supply is available to us to use for drinking, cooking, and other purposes. This small percentage is found in freshwater systems. Freshwater systems exist both above ground as surface water and underground as groundwater. This topic looks at how freshwater systems are linked to one another. These links mean that damage to one system can cause damage to another. By understanding these links, we can take steps to try to minimize damage and maintain healthy water systems for use as well as for other living things. Lakes, ponds, and wetlands. A lake and a pond are basically large holes in the ground filled with standing water. A lake differs from a pond not in size but in depth. In a pond, sunlight reaches all the way to the bottom. In a lake, sunlight does not reach the bottom. Thus, it is possible for a pond to be larger than a lake. The depth to which sunlight will penetrate depends on the water's clarity. Clarity is determined by the amount of matter suspended in the water. Whenever there is a low area in the land, wetlands can occur. There are many different types of wetlands. However, they have one characteristic in common. They are saturated with water all or much of the time. Marshes, for example, are shallow water wetlands, less than 1 meter in depth. They usually remain wet throughout the year. You've probably seen small marshy prairie sloughs. All wetlands provide habitats for an astounding diversity of plants and wildlife. Page 391, streams and rivers. Streams and rivers are both fast-flowing waterways. However, their individual characteristics vary a great deal. Flowing waters differ greatly in speed, temperature, and clarity. They also differ in the nature of their banks and bottoms. All these factors affect the types of plants and animals that live in them. Fast-flowing waterways are usually rich in oxygen, which fish and other animals need to survive. Oxygen dissolves into water as it rushes through rapids or plunges over waterfalls. Water underground. Rivers and lakes are the most visible form of fresh water. However, another important source of fresh water lies beneath Earth's surface. In fact, most of the precipitation that falls on land sinks out of sight into the ground. Below the surface, this groundwater trickles downwards through connected pores and cracks. Eventually, it reaches a layer of bedrock, such as granite. This bedrock layer forms a barrier. When groundwater cannot move any deeper, it begins to back up. It fills the pores in the material above the bedrock. On to page 392. Freshwater links, the watershed concept. Water is always on the move in the never-ending water cycle. No matter where a raindrop lands, it will eventually end up somewhere else. The same is true of ice and snow that melts. All fresh water on Earth, whether surface water or below ground water, is part of a watershed. A watershed, or drainage basin, is the area of land that drains into a body of water, such as a river, pond, wetland, lake, or ocean. When water hits the ground, it either filters into the groundwater or flows downhill. Of course, some also will evaporate. Water that doesn't soak into the ground or evaporate, but instead flows across Earth's surface is called runoff. The area of land within a watershed can be small or large. Within watersheds, there are many smaller ones. For example, every stream is part of a large watershed. A small stream in your neighborhood flows until it meets other small streams. The streams join larger rivers. Large rivers merge into major waterways. A watershed includes both water and land. Each watershed has a variety of habitats. These range from rivers, streams, and lakes to forests and farms. Cities are also part of watersheds. In North America, a continuous ridge of mountain ranges divides the continent into two main drainage areas, as shown in Figure 5.31. On one side, water flows northeast to Hudson Bay or southeast to the Gulf of Mexico. On the other side, water flows west to the Pacific Ocean. This long ridge of mountains dividing North America is called the Continental Divide. Page 393, Watersheds in Alberta. Landforms determine the size of a watershed. They also determine the speed and direction of water flow. High ground, such as mountain ranges and hilltops, directs water one way or another. The upstream areas of a watershed are called the headwaters. The end point of the water flowing through a watershed is called the outflow. The outflow is usually a river mouth. The geography of Alberta determines the direction water will flow. Generally, water located in northern and central Alberta moves towards the Arctic Ocean. East central and southern Alberta rivers flow into Hudson Bay. A very small amount of water in the southernmost part or area of Alberta ends up in the Gulf of Mexico. Go to page 394 now, watersheds and land use. What we do on the land can affect the water around us. If we spill gasoline when we are filling a car, pave over areas for new buildings and roads, or flush the toilet, our watershed is affected. For example, have you ever looked at the ditches or storm drains in your city after a heavy rainfall? They are surging and full of water. This is because the watershed for a storm drain in a city where most of the land is paved over. If the pavement wasn't there, a lot of this water would soak into the soil. It would slowly seep into the groundwater or flow into rivers, lakes, or other bodies of water. Let's go to page 396 now, to runoff and erosion. The amount of rain and the time it takes to fall are two factors. Another factor is the slope of the land. Gentle slopes and flat areas hold water. This gives the water a chance to evaporate or sink into the ground. On steep slopes, however, gravity causes water to run off before much evaporation or seepage can happen. The amount of vegetation, such as grass, can also affect the amount of runoff. Just like spilled milk running off a table, water will run off smooth surfaces that have little or no vegetation. Plants and their roots act like sponges to soak up and hold water. By slowing down runoff, plants and roots help to prevent the loss of erosion of soil. Wetlands, forests, and prairies capture and store more water than paved roads and parking lots. Thus, urban areas have more runoff than areas covered with vegetation. Deposition. Most rivers begin their journey on the steep slopes of a mountain range. Headwaters are usually narrow, straight, and fast-moving. They tumble down waterfalls and form whitewater rapids. The water carries any loose rocks or boulders. A river carries water downhill from the land back to a lake or ocean. As it flows, a river can erode materials from its bottom and banks. Where the river slope is flatter, the river slows down and deposits these materials. This process is known as deposition. This usually occurs in the lower reaches of the river, especially near the mouth. A river can carve steep valleys, especially at higher parts of the drainage basin. In the lower parts of the basin, deposits may cause fan-shaped deltas at the river's mouth. The volume of water flowing into a river determines how the river shapes the surrounding landscape. The speed and timing of the flow are factors as well. Rainflow, snowmelt, and groundwater all contribute to the volume of flow. Stream flow varies from season to season and from year to year. Let's go to page 403 now. So skipping ahead. There's some parts we're leaving out here. I'm sure you're upset. Watershed management and groundwater. More than 25% of Albertans depend upon groundwater for their water supply. Much of this is related to agriculture. Farmers use this water for irrigation, domestic use, and livestock. Groundwater also contributes to the water level in some lakes. Some river systems also depend on groundwater to keep their channels from drying up during low flow seasons. A groundwater system is similar to a river system. However, it does not have channels that connect different parts of the drainage basin. Instead, a groundwater system has connecting pores. Soil and rock are permeable if the pore spaces are connected and water can pass through them. Sandstone is an example of a permeable rock. Soil or rock that has many connected pores is highly permeable. Water can pass through it easily. Soil or rock is less permeable in the connected pore spaces if the connected pore spaces are fewer in number or if the pores are fewer or smaller. Some material, such as clay, has small pore spaces or no pores at all. This material is impermeable. Water cannot pass through it. Some types of rock, such as sandstone, are full of pores and can hold a lot of water. As every space in the rock becomes filled, the groundwater forms a sort of underground river system connected by pores instead of stream channels. This system of water flowing through porous rock is called an aquifer. Like rivers on the surface, the water in aquifers moves, although its flow is very slow. It might take 80 years or more to travel through 1 kilometer of sand. The layer of porous rock, in which all pores are full of water, forms a water table, as shown in figure 5.46. The level of a water table may change, rising closer to the surface in wet seasons and sinking lower in dry seasons. Wells and springs, page 404. Have you ever been to a beach and scooped out a hole in the sand? As if from nowhere, water appears in the hole. Water moves into the hole from the saturated sand surrounding it. In almost any part of the world, even in deserts, a hole dug deep enough will reach water from the reservoir under the ground. Wells are made by drilling a hole through the soil and rock to a point below the water table. Water is pumped up to the surface. If too many wells are dug in one area, they may remove groundwater faster than it is replaced by precipitation. If that happens, the water table will drop and the wells may run dry. Page 405. Aquifer depletion. Underground aquifers are essential water resources for people and nature alike. When too much water is withdrawn for cities, agriculture, or industry, these precious reserves can be depleted. Local supplies fall short. Creeks, springs, and wells for kilometers around can go dry. When this happens, people must truck water in or build pipelines. However, the local plants and wildlife are left without enough water. Using less water is the reasonable response to aquifer depletion. Water conservation leaves more water in rivers, streams, and aquifers, which is good for wildlife. It is also good for us, since many regions experience water shortages during parts of the year. Conserving water also saves us money on water and sewage bills. Let's go to page 406 now, groundwater contamination. Groundwater carries with it any soluble or dissolvable contaminants that it encounters. Any addition of undesirable substances to groundwater caused by human activities is considered contamination. Groundwater can spread the effects of dumps and spills far beyond the site of the original contamination. Sometimes hazardous wastes, chemicals, heavy metals, oil, and other contaminants collect on the surface of the ground. Rain or runoff seeping into the soil can carry these substances into the groundwater. When water quality specialists analyze the quality of groundwater, they consider land use practices in the watershed and in the vicinity of the well. Let's go to page 407 now and talk about too little water. Oh, I passed it. 407, too little water. There's a water dilemma in Alberta. often there is too much water in the large flowing rivers of northern Alberta. This rapidly flowing water can destroy and erode agricultural land. In the south, Alberta's rivers can carry smaller volumes of water. At the same time, the agricultural, industrial, and municipal demand is very high. Some river channels are in danger of drying up during the hot summer months. Managing water in southern Alberta is different from managing water in the north. Much of the water that is used in Alberta is for agriculture, particularly irrigation. Almost 40% of Alberta's population lives in southern Alberta. Nearly 50 of their urban communities rely on irrigation systems for domestic water supply. One example of a water management project is the Western Irrigation District. This water delivery system uses 1,200 kilometers of canals east of Calgary. It delivers waters to farmers, to acreage owners, and to various industrial customers. In addition, it supplies stormwater removal systems and municipal water for several towns. That concludes Unit 5, Topic 3. It was a big one, lots of information. Tune in for the Google Meet session if you get this.